going to do?
We are going to test the wavelength of the Dragonfruit beams using UV visible spectrophotometer.
A few moments later.
Guys, how's your science in life project going?
It's fine. Everything's fine.
Haikal, what is your project about?
So basically, I want to see the color inside of fruit beams.
Do you use any instrument for your project?
Yes, I use a UV visible spectrophotometer.
Ami, do you know what is UV?
Sorry, I don't know. This is like a business project.
Do you know any idea about it?
No.
Oh, okay. So what is UV?
Let me explain.
Oh, okay. Let's go see the UVBs.
Let's ask Haikal.
Let's do it.
Okay.
So guys, here we have maklumat kimia and kimia analisis dan persekitaran. This is where most of the instrument that will be used for SI project is. It also inside is the UV visible spectrophotometer. Hi, Assalamualaikum. My name is Muhammad Aikal. Today I'll be talking about the objective of our research paper. So the objective of our research paper is to find the compounds of dragonfruit beans. From the result, we could create a natural dye based on leftover from fruit. By using leftover peels, we would essentially reduce the amount of waste people throw out every day. Also, it will reduce the amount of artificial dye being used in today's industry by replacing them with a natural one. In turn, we would save the environment and reduce the chemical in our daily usage. Thank you, that's all for me.
For this experiment, we are testing the wavelength of Dragonfruit extract using UV visible spectroscope. So now, let's go to apparatus and materials that are required. So, we use the following materials: 99.7% ethanol, distilled water, dragonfruit prints, and finally, dye extract. So now, let's move to the procedure. First, we remove the peels from the dragonfruit and cut them into small pieces. This increases the surface area for greater extraction. Next, we use a mortar and pestle to crush the peels, helping to release the pigments. Third, when we transfer the crushed peels into a beaker and added 99.7% ethanol in a 1 part peel, 2 parts ethanol. Next, the mixture was left to incubate for 12 or 24 hours to allow the pigments to fully dissolve in ethanol. After incubation, we filter the solution using filter paper to remove any solid peel residue. We repeated this process twice to ensure purity. And finally, the filtered extract was transferred into a container with a yellow cap for storage before analysis. This extract was then analyzed using the UV visible spectrophotometer to determine its absorption spectrum and identify the unique present in the dragonfruit. So that's it.
So, how does UV spectroscopy work? Imagine you're wearing sunglasses on a bright day. The lenses absorb some of the sunlight, letting only a certain amount pass through. UV spectroscopy works in a similar way. It measures how much light is absorbed by a substance at a different wavelength, helping us understand its properties. This is a step-by-step of UVs. First is light source. The instrument uses UV light between 200 to 400 nm and visible light 400 to 700 nm. This light shines through a sample, just like sunlight passing through tinted glass. And secondly, monochromator, which is color filter. Before the light reaches a sample, a filter, which is monochromator, select a specific wavelength, so only one color of light goes through at a time. Next is sample interaction. The selected light passes through the sample, which could be a colored solution like dragonfruit extract or a clear liquid with dissolved chemicals. Some of the light is absorbed while the rest passes through. And the next one is detector measurement. The sensor detects how much light got through versus how much was absorbed. More absorbance means the sample has higher concentration of the absorbing substance. And the last one is data output, which is absorption spectrum. The spectrophotometer creates a graph showing how much light was absorbed at a different wavelength. For example, if you analyze dragonfruit extract, you'll see a peak around 535 nm, meaning that's where the red pigment absorbs the most light.
For the result, the graph shows how absorbance changes with wavelength. There is high absorbance in the UV region, which is 200 to 300 nm, with several short speeds. After 300 nm, absorbance gradually decreases and stay low beyond 500 nm. For discussion, the high absorbance in the UV range suggests the presence of compound that absorb UV light. Possibly due to the conjugate or aromatic structure, the sharp peak may be due to the instrument noise or sample impedance. The low absorbance in the visible range, above 400 nm, indicates that the sample does not strongly absorb visible light and may be colorless. Reducing noise and repeating measurement could help improve accuracy.